Hello, everyone. It's Mr. Slomka, and today we're going to finish up our notes on section 3.2 by doing a couple of proofs together. So I wanted to remind you of a couple of the theorems that we had talked about in the beginning of section 3.2 so that we could then use them in some of these proofs that I want to talk about today. So our four basic theorems are the corresponding angles theorem, the alternate interior angles theorem, the alternate exterior angles theorem, and the consecutive interior angles theorem. Most of these are very similar, but there is one that is a little bit different. So to begin with, our corresponding angles are going to be congruent to each other. Our alternate interior angles are going to be congruent to each other, and our alternate exterior angles are going to be congruent to each other as well. So that matches up really, really nicely. As long as you have parallel lines, you have congruent angles. So what you see is what you get, and that works out great. The last set, the consecutive interior angles, are slightly different. If you take a look, we don't use the word congruent anymore. We use supplementary. And remember that when we say something like supplementary, what we really mean is that those angle measures are going to be adding up to give you 180 degrees. So they don't match, but they are related to each other. So 4 and 5 right here are good consecutive interior angles, and they don't even look the same, but that's okay. They're related to each other by that term supplementary. All right, let's see if we can put some of these guys to work in some proofs. Okay, so the two proofs that we're going to do today are actually going to be proving that some of these theorems that we just learned about exist and work. That's an interesting thing about a theorem as opposed to a definition. If you have something that is a theorem, it can be proved. You can show that it works, and that's great. A definition can't necessarily be proved. So what we have right here is we have a proof where we're going to show that the alternate interior angles theorem is going to work out great. What does that mean? Well, it means that you're not actually allowed to use the alternate interior angles theorem when we write this proof. So our alternate interior angles are 1 and 2 in here, and I want to show that angle 1 and angle 2 are congruent to each other, but I'm not allowed to use alternate interior angles in order to do that. So let me show you how we're going to go about it. To begin with, we're going to state our given statement, which is going to be that P is parallel to Q, and it is our given statement, so we get to write given here. As you know, I always love to mark the drawing, but if you take a look, our drawing's already been marked for us. And so you can see that the two lines are parallel already. Okay, so now I can't jump right into talking about angle 1 and angle 2 because I'm not allowed to use the alternate interior angles theorem. So that means they've provided us with a third angle here, which is called angle 3, and we need to see if we can reference that guy. Now, angle 3 is going to be related to some of the other angles, and you can attach angle 3 to angle 1 or angle 3 to angle 2 in a number of different ways, and you can do it in any order you'd like. I'm going to be boring, and I'm going to talk about how angle 1 and angle 3 look like they are the exact same size. If I am going to make a statement like that, then I need a really great reason why. And what I'm noticing about angle 1 and angle 3 is that each of them is on a parallel line, and they both share the transversal. They are located to the left of the transversal, and they're both below their parallel line. Those are corresponding angles. So I can use my corresponding angles theorem to state that those two angles are going to be congruent to each other. Excellent. Okay, so now that's great, but we also need to talk about angle 2 as well. So let's see if we can get him in the mix. And what I'm noticing is that it looks like angle 2 and angle 3 are the same size as well. So I'd like to see if I could bring that up in my proof. So I'm going to say that angle 3 is congruent to angle 2. I'm going to need a really great reason for that type of statement as well. And what I'm noticing is that the only thing separating angle 2 from angle 3 is a vertex, which means that they're vertical angles. And I can use my favorite vertical angle congruence theorem. So I'm going to use that. Okay, great. What have I done here? What I've done here is I've built two congruent statements, which is great because that's really what I'm supposed to get to, a congruent statement. And I also noticed that in my congruent statement, I've already incorporated angle 1, which is awesome, and angle 2, which is also great. The only other thing that is in these statements is angle 3. And the best part about angle 3 is that it shows up in both statements. Angle 3 is congruent to angle 1, and angle 3 is congruent to angle 2. And because of that, what we can do is we can make a new statement that doesn't use angle 3 anymore. It's just going to grab the angle 1 from statement number 2, and it'll grab angle 2 from statement number 3. And our last and final statement can be that angle 1 is congruent to angle 2. What is a great reason? Well, like I said earlier, I would love to say alternate interior angles because that's what they are, but I can't. And so I'm going to need to come up with a great reason. The reason why I get to say that these things are congruent doesn't have to do with the picture. It has to do with what I wrote in the proof. And that means I'm going to use one of my properties that I use to switch around my different facts. And the property that is going to work best in this case is the transitive property. There you go. That's a complete proof right there, and it works out great. Here's what I'd like you to do. I'd like you to do almost the exact same proof. This time you're proving the alternate exterior angles theorem. Your picture is very similar. Your proof is going to be very similar. Give it a shot right now. Pause the video. All right, we're going to start off with our given statement that P and Q are parallel to each other again, and it's already marked on the drawing, so that's great. So the next thing we need to do is we need to see if we can jump in on those angles. The two angles that we're really aiming for is 2 and 7 because those are the alternate exteriors, but we can't jump right to those. So we're going to need to see if we can incorporate angle 5. And not surprisingly, you'll notice that 5 and 7 are very closely related to each other. So I'm going to make a statement about that. They're vertical angles, and so I can use my vertical angle congruence theorem to state that they are going to be congruent to each other. Also, something very similar to what we've seen before is 2 and 5 are congruent to each other, and I need a great reason for talking about them being congruent. Well, once again, I noticed that they're both sharing the same transversal. They're both to the left of that transversal, and they both have their own parallel line, and they're both above that parallel line, which means they're corresponding. There's no alternating happening here at all. Those are corresponding angles. So I can use my corresponding angles theorem. All right, my last step right here, the part that I'm really trying to get to. If you notice, once again, I've made a couple of statements that both involve angle 5, which means we don't need to use angle 5 anymore. We can now bring down angle 2, and we can bring down angle 7, and we can make a new statement that just involves angle 2 and angle 7. And the reason for that, once again, I would have loved to use alternate exterior angles theorem, but I can't because I'm not allowed to. So I am going to be able to just have to use my proof statements, which means I'm going to use the transitive property to move those statements around. If you wanted to write this proof again, now that we've done it together, if you wanted to write this proof again, you could, and it would actually be a lot faster. Now that we've proved that the alternate exterior angles theorem works, you could jump right from saying that you have got a set of given parallel lines, and you could jump right to saying that angle 2 is congruent to angle 7. We did all of the hard work together, and that means that you never have to do the hard work again. You can now benefit from the fruits of your labor and write this proof in just 2 steps, which is a lot quicker and a lot better. So by all means, feel free from now on to use those shortcuts. You can use the alternate interior angles theorem. You can use the alternate exterior angles theorem as much as you would like.